Hi, I'm Darren and welcome to Level Up Double E Lab. Well, I have yet another piece of Heathkit gear to talk about. It's an HG-10 VFO. Let's check it out. My recently restored Heathkit DX-60 is a bit lonely, so I thought I'd get it a companion. How about a nice Heathkit HG-10 VFO? Perfect, that's exactly what it needed. I only have a handful of old crystals, so using a VFO will let me enjoy operating the DX-60 over the full amateur HF spectrum. And this particular unit is in very good condition, unlike the starting conditions on my DX-60. All three controls are operating smoothly. That's definitely a great start. Let's take a look around back. The HG-10 gets its power from the transmitter, so that's why it has this octal plug cable. I'm going to assume for the moment that this extra bit of line cord is for an AC antenna relay. That's a bit dicey. But notice the paint, it still has its shine. The cosmetic appearance of this HG-10 is really good. In fact, the only thing noticeable are the knobs. Now, they are quite dirty, but that's easy to remedy. Let's have a look now at its inside condition. There are 5 screws holding the cover on, 1 in the back and 2 on each side. One of the 4 side screws is missing. In fact, it looks like it broke off. The top deck is very simple. There's just 2 vacuum tubes and some adjustable inductors and caps for alignment. The tubes are a 6CH8 triode pentode combination and an OB2 voltage regulator. And look at this, they're both marked as Heathkit Daystrom. It's quite possible that these are the original tubes. I'm going to pull them out and set them aside before I go any further. Let's take a peek inside. There are 11 screws holding the bottom panel on. I guess Heathkit really wanted it to never fall off. Or more likely, they wanted to ensure good bonding around it for shielding. There's a mix of flathead screws and non-Heathkit standard hex head screws holding it on, so somebody's been in here before. The moment of truth. What am I going to find inside? Wow, it looks to be mostly, if not completely, original. Also, the workmanship looks really good too. Even the point-to-point wiring is neatly routed. Whoever built this back in the day definitely took their time and did it with care. It's really clean too. It clearly was never exposed to a dirty environment, nor is there any odor of it having been used by a smoker. So all things are looking very positive with this initial assessment. If you kept up with my series on the restoration of that Heathkit DX-60, in one of those episodes I said that I wanted to get a VFO, either a VF1 or an HG-10, and I was just going to wait until I could go to a Hamfest or two and pick one up that way, but I was also keeping my eye on eBay, and this one came up at the right time at the right price. Now, my DX-60 was a difficult and lengthy restoration, but I'm pretty optimistic that this guy may only need a cleaning and maybe an alignment. It is in that good a shape. Now, I have checked all the resistors. There's 11 of them in here, and a couple are slightly off 10%, but they're not so far off as to need immediate replacement. Plus, they're buried down in here. They're hard to get to, and I'd have to tear apart a lot of this really neat construction to get to them. So if I don't have to do that, I'm not going to do that. There are 31 capacitors in the design, but fortunately, none of them are electrolytic. There's also no film caps in this design. They're all ceramic and mica, and of course, air adjustable. So there's nothing there that will be prone to degradation. Also, the switches look to be in really good shape. I don't even think they need to be cleaned. They're that good looking. And then lastly, the gear train is working very smoothly. This is one area on these HG-10s that I understand can go wonky if it wasn't assembled right from the beginning, or if it's worn out or got contaminated, but this is turning very smoothly. There is a fair amount of grease on here, so it might need to be cleaned up, but I think I'm just going to leave it alone for now. So what I need to do next is get this on a power supply and check out its function. Here's the power supply I want to use. It's a Heathkit EUW15. Now, it's a bit of a unique animal. It's actually part of a whole series of lab equipment that Heathkit marketed years ago under the Heathkit Heath-Built brand. And there was even a textbook that was written around all this equipment, Electronics for Scientists. And it showed various experiments that you could do to learn vacuum tube and solid state electronics, how to apply them specifically to a engineering laboratory for like data acquisition and so on. Very interesting combination and set of equipment that Heathkit put together. And I actually have 3 videos I did on the restoration of this power supply. It's ideal for testing out this HG-10. It has an adjustable and regulated high voltage DC between 200 to 300 volts, up to 100 milliamps, so plenty of range and plenty of power. It also has 6.3 volts AC up to 3 amps, and that's ideal also for driving the tube filament that's in here. The one vacuum tube, the 6CH8. The problem, though, is even though it looks like I could just plug this in and be running away, there's, octal sockets right here. Well, the problem is, there's actually 2 problems. The first is the pinout of this cable doesn't match the pinout of these sockets. And there's no reason it should, because Heathkit did this proprietary design just for their needs. This was a completely different product, so there is no universal standard for what the pinouts on these sockets and cables should be. So that's not compatible. It's easy to fix that, though. I can make a little adapter like this. Plug this in here and hook up to the binding posts and be in business, right? Well, no, there's another more serious problem, and I'll put the schematic on screen for this EUW15. There's actually a center tap on that 6.3 volt AC winding, and that center tap is connected internally to the low side of the high voltage DC. Heathkit apparently did that to limit the voltage difference between the filament and cathode in one of the internal tubes, but that creates a huge problem because the low side of the high voltage DC and one of the 2 sides of the 6.3 volt AC are connected to ground on the HG-10. And if I did connect this to that, I'd end up shorting that entire secondary filament inside the power supply. So that would be, or secondary winding rather. So that would be bad. I can't do that. So I could remedy that if I hack up the power supply, but I don't want to do that. So instead of hacking up my EUW15, I made a very simple AC power supply instead. And these are all parts that I just had laying around in the junk box. This is a salvaged 12.6 volt AC center tapped transformer from something I don't even remember where I got it from. Reused housing, reused enclosure here. And of course I've got a fuse. You can't see it inside the box on the primary side. And this has enough power to drive. It's just under it's like 900 milliamps, just under 9/10 of an amp to drive the heaters in the 6CH8. So that'll take care of that. And I can connect, say, this side of the 6.3 volts to the chassis, which would interconnect back to the EUW15. I can do that safely because this is isolated and I won't be causing any short circuits or harm there. So this may seem convoluted. One obvious question is, why not just plug this into my DX-60 and be done with it and test it out that way? Well, 2 reasons. First of all, it's not good practice to power equipment of unknown condition by plugging it into a semi-precious piece of other gear. And I would not want to damage my recently repaired DX-60 if there was a serious flaw in here. That's what test equipment is intended to be used for. I mean, you might damage a power supply or cause some trouble there, but that's the purpose of test equipment, is to be evaluating another piece of gear in an isolated environment. And the second reason is that would just be too easy. Sometimes doing it the hard way is more rewarding, and I also deliberately wanted to show a way of testing out this guy without having to use, another piece of, another transmitter or transceiver rather to power it up. Just use power supplies and check it out. So I'm going to get this hooked up now and take a look at its output up here on the scope.
This item contains hazardous voltage and safety precautions must be followed. If you're following along and working on your own version, you're doing so at your own risk.
Okay, I got the power turned on and the HG-10 is working just fine. We can see on the signalant here in the background, that's the sample waveform output on 80 meters. And clearly it's not a pure sine wave and it's not supposed to be. I'll talk about that here in a moment. But a couple other things to point out before I do a zoom in on the screen here of the signalant. I did have to replace the transformer here on my quick 6.3 volt AC power supply I whipped up. Made a rookie mistake. I grabbed a transformer that had the right output voltage, and I checked to make sure it could supply the current, but I didn't check the output voltage drop when it was putting out that current. And as it turns out, I was saturating the core. The voltage was dropping to about 4.5 volts, which is just inadequate to light up the filament, and that's 6CH8. So luckily, I had another transformer I could put in place, and it's adequate to supply that current without any appreciable voltage drop on the secondary. So we're good there. And then, of course, I needed to set my EUW15 to appropriate high voltage. I measured about 335, 340 volts on the DX-60, so that's what I've got it set to. And it's working. And the OB2 voltage regulator tube has a nice orange glow going on there, so it's doing its job. And then, of course, the 6CH8 is liking the 6.3 volt AC that I'm feeding it. So at this point, I think it'll be interesting to take a closer look at the output waveforms on the various amateur bands. So let me do that next by resetting the camera. Okay, slight change of plans here. I was going to zoom in and show the output waveform in all of the bands, but as I was setting this shot up, something unfortunate happened here. See if you guys can figure out what's going on. You can see in the background the output voltage profiles are changing, but the scale stopped turning. So what has happened here is one of my favorite things to fix on old rigs. The dial string is broken. You can see it flopping around in there. So I'm going to have to stop recording for a moment and figure out how to fix that. Okay, so about an hour and a half later, back in business. I got a replacement dial cord in there and things seem to be working okay. It's not a terribly easy repair to make. It's difficult to fish it in behind the main dial cord because that's the way you would ordinarily build this. You'd put this cord on first and this one on second. I don't want to take this off, so I kind of fished around. And of course I had to reset the position of the drum to make sure it aligned with the aperture in the panel. And it's not perfect. It gets it pretty close. But I guess one small upside, it makes it easy now for me to clean the panel. And I got to clean the knobs anyway. So let me get it buttoned back up, reconnected to the power supplies, and then we can take a look at the output. Okay, I put the front panel and the knobs back on the HG-10 and connected it back up to power so we can take a closer look at the voltage output. I suppose I could just take some screenshots on my Siglant, but I'm going to be skipping through the bands here, and I think it's easier just to do a live video recording, even if the quality is a little less good than just taking the screen captures. But nonetheless, it's very obvious that this output waveform is not a perfect sine wave. In fact, it's nowhere near a sine wave. Just the way the circuit works, I got it set on 80 meters, and there's a harmonic in there for sure, but the fundamental is right about 3.5 megahertz. And that's where I have the dial set. Now, the HG-10 is not going to be as accurate. In fact, nowhere near as accurate as a modern digital VFO. In fact, right now it's reading about 5 kilohertz high. That's not a problem because you're going to use the DX-60 with this HG-10 with a receiver that you're going to tune in to a more accurate frequency. It's typically what I do. My receivers are going to be much more accurate for absolute frequency, and you're just going to tune the transmitter to match where you want to respond to someone who's sending CQ or get set up on your receiver to call CQ. So I'm not going to fuss around with trying to calibrate this, and I'm also not going to fuss around with the stability because, again, I'm going to use it with a receiver that's going to be much more stable. And if the HG-10 does drift a little bit, well, that's what RIT is for, receiver increment tuning. Anyway, digressing a little bit, this is what the 80 meter signal looks like. Let me switch it over to 40. And you see it kind of drop that funky harmonic that was in there, but it's still, again, nowhere near a sine wave. This is right at about 6.9988, so it's a little low. But again, that's fine. I'm not worried about that. Now, one thing to notice here, I'm going to switch to 20, and I'm going to switch to 15, and I'm going to switch to 10, and the output frequency didn't change. Again, this is where the harmonic content is going to be exploited by the DX-60, and you're going to tune to those second, third, and fourth harmonics for those bands. So the last two to look at here is 6 meters, and it does change frequency. It starts at 8.333 megahertz and goes up to 9 megahertz, which is the 6th harmonic for 50 megahertz. And then if you really want to use this bad boy on 2 meters, you can use the 18th harmonic. In this case, it's 8 megahertz to 8.222. So all in all, this seems to be working okay. At this point, I'm going to put the cover back onto it and wrap this video up. Of course, I do have to show the HG-10 working with my DX-60, so here we go. It's all connected together. And since I finished the series on the DX-60, I did replace this 2-element resistor power block. If you recall from that series, I realized that these were way undersized and were running way too hot. So I came up with a set of 4, and I've got that in the DX-60, and it's running a lot cooler now. As far as the rest of the setup goes, I've got a dummy load off to the side, and in between it, the DX-60, you can't see it, but behind the HG-10, I got my RF power tap, so we can take a look at the sampled signal up here on the Siglent. So it's all set. I've got it tuned already for 40 meter band for 7.1 megahertz. So here we go. There's no side tone, so I can't hear me sending a CQ into the dummy load, but it's working. So compared to my DX-60, having to fix just a broken dial cord here on this HG-10 means I got off pretty light, and I'll take it because sometimes you want projects that really aren't that complicated. So I do hope you enjoyed this short video on the HG-10 VFO, and I know I'm going to look forward to using it with my DX-60 and making some contacts. So until next time, bye for now.